Hello and welcome. In this video, I'm going to go through the Additional Mathematics Form 5 Kssm Chapter 2 Differentiation textbook question. This is Formative Exercise 2.1. My name is Terry. If you enjoyed this video, please click like, and if you want to receive more notification when we upload a new video, please subscribe, and also leave a comment if you have any question about this the question discussed in this video, and also if you think there's certain things that we can improve on. So let's get straight to this. Okay, the first part of this practice is about the idea of limit. Right now, idea of limit usually is not a very popular exam question in SPM, but it's something that you should know. All right, and in this question number 1, you're supposed to find the limit of function fx when x approaches -1. So you're already given the graph, so we can just look at the graph, and from our graph we can see that when x approaches 1, which is here, -1, sorry, over here, can you see your y value or your fx value approaches 8. So your answer for a Roman 1 is just 8. Yeah, or perhaps I'll just write here 8. Very simple, just read from the graph. The second one, limit of x approaching 0 for fx. Okay, when your x approaches 0, can you see 0 here? Your y value actually approaches 3. So your answer is just 3. Roman 3, how about x approaches 1? Okay, so you can see when x equals to 1, we can just substitute inside your function if you like, but you're just going to get 0, right? So this answer is just 0. So I'll just write next to the question itself. Okay, next I want to find the limit of x approaching 2. Okay, when x approaching 2, what's your y value? Your y is actually at -1. Now how about x approaching 3? Again, at 3, your y value is just 0. And lastly, when x approaching 4, okay, the problem is I don't have 4 here, but you can see that the graph is actually symmetrical at 2. Yeah, this is a quadratic function, symmetrical at 2. So from 2 to 4, you actually move 2 units. If you move over here, it's also 2 units, right? So you can see 4 is actually at the level of 3. Your y value or your fx value is supposed to be 3. Okay, next, let's find out the possible value of a given that limit of x approaching a for fx is now 8. Now you can see from the graph when your y value is 8, your y value is 8, maybe I highlight from here, you can see your x value is -1. So you just have to move this over and read from here. Now again, because of the symmetrical nature of your graph, right, you can count the number of boxes from the axis symmetry. This is 3, number of units. So this is also 3. So 2 plus 3 will give us 5. So you can see that the possible value of a should be what? Either -1 or just 5. Okay, when your y is 8, your x value is either -1, you move over here, it's 5. I know it's 5 because I can just count the number of units from the axis of symmetry, the middle line here, right? Because it's symmetrical, it's a quadratic function, it's symmetrical at x equals to 2. So we know answer should be 5. All right, the next part, C, determine the gradient of tangent by using the first principle. Okay, so here I need to move this up a little bit. Okay, what we want is to find the gradient using first principle. Okay, the function is y equals x squared minus 4x plus 3. So I'm just going to call this, this is C Roman 1. I'm just going to call this y equals to x squared minus 4x plus 3 as my equation 1. Then I'm going to sub x plus delta x, y plus delta y inside. I'll get y plus delta y equals x plus delta x, I square it, minus 4, x plus delta x plus 3. So when you expand, you get x squared plus 2x delta x. Okay, I hope you know how to expand this quickly by now. A plus b squared is a squared plus 2ab plus b squared. So when you have x plus delta x squared, you get x squared. 2 times x is 2x. you multiply with delta x, and delta x, when you square it, we can just write like this. Now remember, delta x squared is actually delta x multiplied with delta x, right? So I have to write delta x squared here, minus 4x minus 4 delta x plus 3, and I'll call this equation number 2. Now remember, what we want to do is to find the gradient of tangent. Now the first principal concept is such that we know that dy dx is your gradient of tangent, and we need to first find gradient of chord delta y over delta x, right? So however, we know they are actually different, they have different gradient, unless when you take your x value, delta x value, you let it approach 0. So we say that dy dx is actually the limit of delta x approaching 0 of delta y over delta x. So just based on this fundamental principle, we are going to form or find the gradient of tangent dy dx. So I'm going to take equation 2 minus equation 1. When you subtract 2 with 1, you get delta y. Okay, let me just highlight for you. When you take 2 minus 1, these two cancel out, these two cancel out. Basically the one with x, the one without delta x, sorry, will just cancel out. So you're left with 2x delta x plus delta x squared minus 4 delta x. So I'm going to divide by delta x. So delta y over delta x is now 2x plus delta x minus 4. Remember, delta x divide by delta x. Yeah, this delta x squared divide by delta x is just delta x. When you divide this, you can basically cancel all the delta x. Okay. All right. Now, we're not done yet. This is your gradient of chord. I want to find gradient of tangent, dy dx. dy dx is your gradient of tangent. So we have to take the limit of delta x approaching 0 of your delta y over delta x. So I'm going to put 0 inside. So this is 2x. If you put 0 inside here, you're left with 2x minus 4. So this is what we call the gradient function. So here they say gradient of tangent function. Actually, it's gradient function. And gradient function is basically the function that represent the gradient of tangent at different point of the curve, right? So I want to find the gradient at a point x equals to 4. So when x equals to 4, I wrote wrongly, x equals to 4. When x equals to 4, my dy dx will be 2 times 4 minus 4, which is 8 minus 4, answer is 4. Now if you want to understand how this thing works, okay, maybe I just rub this off and I show you from the graph. Okay, so what we know is that this curve here, maybe I use at the point where x equals to 4 over here, you can draw a straight line. Okay, maybe I should use a different color, blue line. Okay, so it's contrast a little bit. So this is a tangent. When x equals to 4, this gradient is also 4. Yeah, so that's the meaning. Okay. Alright, so we're done with question 1, so let's move on to question number 2. Okay, so in question number 2, now we're going to find the limit for each one of this. Okay, so alright, some limit questions are quite straightforward where we can actually substitute directly, like A, we can just substitute directly. Okay, I should use the black pen. Alright, so when you take the limit of x approaching 0, right? Alright, for part A, limit of x approaching 0, x squared minus 6x plus 9, we can just substitute inside. If you put 0 inside, 0 inside, what do you get? You just get 9. Okay, so for part B, I think I'll do B here. Now, again, we can just substitute inside the limit of x approaching 2 of cube root of x power 4 minus 2x power 2. If I put 2 inside, I will get cube root of 2 power 4, which is 16, 2 power 2, which is 4. Basically, it's the cube root of 8. Answer is just 2. Okay, now, however, I need to point out this. If you put 9 inside here, so what happened is that, okay, let's say I just put 9, so I get 9 minus 9, 9 squared minus 81. You will get 0 over 0. Every time you get 0 over 0, we call this as what? Indeterminate form. So we cannot actually find the exact value. Now 0, I know 0 over 0, I know some people say is 1. It's not 1. You have to think this way. Give me a number close to 0. Let's say we take a number close to 0 0.00000001, right? You divide by another number close to 0 0.00001. Now, the problem is I do not know how many 0 I have here. I can have 10 power negative, let's say 99. Then this number can be 10 power negative 70, right? Then if I take another random number that is slightly, let's say, negative 75, and another random number, let's say negative 101, then every time I take a random number close to 0, divide by a random number close to 0, I'll always get a different answer. I know you guys be thinking, how about other numbers? Like, does this only apply to 0? Yes, because if you take a number close to 2, okay, let's say we take a number close to 2.000001, divide by a number close to 2, can be slightly less than 2, let's say 1.99999999999. If you use your calculator, you always get 1. You can try with other number, 3, 4, 5, even negative number, except 0 over 0. Now, another thing about 0 over 0 is that a number close to 0 that is slightly positive, okay, this is something extra, is called 0 plus. A number close to 0 that is slightly negative, like negative 0.0001, is called 0 minus. So if I take a random number close to 0, divide by the random number close to 0, now we don't know whether the number is a positive number or a negative number. One time I can get a positive, one time I can get a negative, then I divide it, I always get different answer altogether, right? So that's why we say 0 over 0 is indeterminate. Yeah, you cannot determine the exact value. So what to do in the event that you get 0 over 0? Okay, this is what we have to do. We have to simplify by factorizing. So here we cannot sub in the limit yet. We have to factorize this. Now for me, I can see that my denominator is in the form of a square minus b square, where I can factorize to a plus b, a minus b. So this will be x plus 9, x minus 9. In my numerator, I can take out negative x minus 9. By doing so, I can now cancel x minus 9 from here, and I can now substitute. Yeah, let's simplify first. Let's put 9 inside. This is 9 plus 9, 1 over 80. Okay. All right. So further on factorization. Okay, let's look at D. D is another example that you have to factorize first before you substitute. You can see from the question, I'm copying down the question for you. Now, if you put 2 inside, you get 4. You put 2 inside, you get 2. 4 minus 2 minus 2, you get 0. If you put 2 inside, again, I'll get 2 minus 2, 0. So 0 over 0 again is indeterminate. So we have to do something. And in this case, what we have to do is to factorize top only. Bottom don't have to factorize. Yeah? It's already a single linear expression. So I'm going to put 2 and 1 minus and plus, right? And from here I can cancel these two. I'm now left with the limit of x approaching 2 of x plus 1. So if I put 2 inside 2 plus 1, the answer is just 3. Okay, moving on part E. Now, again, you notice that if you put x equals to 1 inside, so what happened? You get 1 minus 1 and another 1 minus 1. So again, you get 0 over 0, right? If you sub inside, you get 0 over 0. So again, indeterminate. So what we can do is we factorize the numerator, take out x, left with x squared minus 1. All right, and we can actually factorize this one more time. Now, how do I factorize this? This is x plus 1, x minus 1, x minus 1, and we can cancel these two off. And now you're left with x and x plus 1. Okay, let me just write one extra step for you. X plus 1, and when we substitute, you should get 2. Okay, let's look at part F. Okay, now again, if you look at this question, limit of x approaching 5 of x squared minus 7x plus 10, your denominator is x squared minus 25. We know again, if you put 5 inside, you're going to get 0 over 0. Okay, so we need to factorize. Okay, how to factorize the numerator? X minus x 2 and 5, both are negative to get 7. Your denominator is x plus 5, x minus 5. Again, you can cancel them. right? Oops, I better use a different color pen, easier to see. So you're left with x minus 2, x plus 5. So keep writing limit until after you substitute. The moment you substitute, don't need to write limit anymore. 5 minus 2, 5 plus 5. Answer 3/10. Alright, okay, I hope this is not too difficult. Alright, let's look at number 3. Alright, so now this one involving cert, and you've learned this in Form 4, right? Simplification of cert. Now again, you notice if you put 0 inside, okay, let me put 0 inside. I get 1 plus 0, then 1 minus 0, and I get 0. Basically, I get 1 minus 1 over 0, 0 over 0, which is indeterminate form, right? So we cannot do this. We have to simplify first. Now, how do you simplify cert? Okay, we can simplify cert by multiplying top and bottom with its conjugate. So this is square root 1 plus 2x minus square root 1 minus 2x divided by x. Okay, the conjugate of square root 1 plus 2x. Now, this is a minus sign. Take note, I had to put a plus sign. It's like a twin brother or twin sister, if you like. So it has to be the opposite. And you need to multiply top and bottom with the same thing, right? So this is 1 plus 2x, 1 minus 2x. Okay, so when you multiply top and bottom with this, what happened is, again, we use the idea of a minus b, a plus b. When you expand, you get a squared minus b squared. Now your a here has a square root. The moment you square it, the square root disappears. You're left with 1 plus 2x and 1 minus 2x, right? As for your denominator, we do not want to do anything with it. We're just going to leave it like this, right? Now, notice we can cancel out. A 1 minus 1, 0. 2x minus minus 2x. So it's 4x here. With the x, with a bracket 1 plus 2x plus 1 minus 2x. And I can cancel my x. Yeah? So I'm left with 4. So I think because of space constraint, so I'm just going to sub in directly here. So I cancel the x, right? No more x. I'm just going to put 0 inside. So it's 1 plus 0 plus 1 minus 0. So you get 4 over 2, which is just 2. Yeah? Sorry, space limitation. I have to, do it this way. So I still have to do part B and C, which is a bit of a challenge to squeeze everything in here in the screen. So let's look at B over here, and I will continue over the other side if I can't finish all. Okay, let's look at limit of x approaching 4, 3 minus root x plus 5 over x minus 4. Now this cert may appear to be a bit easier because you only have one square root x plus 5. So the conjugate of 3 minus root x plus 5 is 3 plus root x plus 5. Again, you need to multiply top and bottom with this, and we can simplify it. So this is still limit of x approaching 4. 3 squared is 9, then you minus x plus 5. Now your denominator, we are not going to do anything. We're going to keep this first. Alright. And 9 minus x minus 5. We just think 9 minus 5. 9 minus 5 is what? 9 minus 5 is 4 minus x. Now, I can see that there's something I can do because I can actually simplify this term. Okay, let me just point to you. I can simplify this, right? Because this is x minus 4. The top is 4 minus x. So what we can do is to factorize the negative to get 4 minus x. I hope you know this. A minus b, when you take out negative, becomes what? B minus a. When you times in, you always get the same term, right? So by factorizing this, I can now cancel these two off. So I am left with, let me continue here, the limit of x approaching 4 of 1 over, there's a negative here, doesn't matter whether I put a negative in front or below here, 3 plus root x plus 5, right? Now I'm going to sub 4 inside, so this negative 1 over 3 plus square root 4 plus 5. Now 4 plus 5 is going to give us 9. Square root of 9 is 3. 3 plus 3 is just 6. Okay, so that is part B. Okay, moving on to part C. I'm finding the limit of x approaching 3 of x squared minus 5x plus 6 divided by 2 minus square root x plus 1. So here I would need to multiply with the conjugate. Now your conjugate sometimes may appear in your numerator, sometimes your denominator. Now notice for A, it appears on your numerator, B numerator, C denominator. So you just follow, see which one it appears on. So like for example, in this case, you notice this is a minus. So we have to put a plus, the opposite, the twins if you like, right? So, okay, I'm going to erase this. So let us simplify. Now it looks like your numerator, you can actually factorize this. So I'm just going to factorize first because I think we can actually simplify further. So I'm going to factorize this to x minus 2, x minus 3 with a 2 plus square root x plus 1. Now as for your denominator, we're going to use a squared minus b squared. 2 squared is 4. This will be x plus 1. And notice when I simplify this again, okay, maybe I'll cut short my working a little bit. Okay, I tell you what, no need lah. I don't want to make things too complicated for you. So I'll just keep this first. You can see your denominator is 4 minus 1, which is 3 minus x, right? Now notice that we can actually simplify one of these, right? So it's either you factorize the top or you factorize the bottom, factorize the negative. So I think I will just take out the negative from my denominator here. So I get negative x minus 3. And from here we can cancel them, right? Okay, because of space limitation, I'm just going to sub inside directly. I'm going to put 3 inside, 3 minus 2, right? This will be 2 plus square root 3 plus 1. And your denominator is just negative 1, right? So you're left with 1 plus 2 plus 2. Square root 3 plus 1 is square root 4. Square root 4 is 2. 2 plus 2 is 4. So it's 1 times 4 over negative 1. Answer is negative 4. All right, this looks quite long, right? Okay, moving on to question number 4. All right, okay, number 4, this question is a little bit unique because normally they will ask you to sub inside the limit, and we of course have to do some modification first before you substitute. Modification as in you to factorize or you rationalize the denominator or simplify first. But here, if you look at the question, we are given limit of x approaching 2 of x squared minus k of 3x minus 6 equals to 4 over 3. Now, so this is a question mark. So can we substitute 2 inside? Yeah? Can we substitute 2 inside? Answer is no. Because if you substitute 2 inside, your denominator will become 0. True or not? Yeah? So your denominator will become 0. So now obviously we cannot, something 0, only 0 over 0 is indeterminate, right? So we know that your top or your numerator must also be 0. So there are two ways of thinking. The first method of thinking is, okay, maybe I know that I will have to factorize this. Maybe I shouldn't write equal sign here. I know I will have to factorize the denominator and get x minus 2. And your numerator, obviously, we should be able to factorize x. The problem is the k will be either square root k, 1 positive, 1 negative. Right? And we know these two, we should be able to cancel one of them. But to be able to cancel these two, right? Yeah, to be able to cancel these two, we know square root k must be 2. Square root k must be 2. Correct? So k must be 4. Another way of thinking is that we know that after you substitute, right, and you cancel this. Let's see, I cancel this already. Maybe I make it a bit darker. You're left with square root x plus square root k over 3. And when you put 2 inside, we know the limit is going to give us 4 over 3. So that means if I put root 2 in, I put 2 inside your x, so this will be 2 plus root k over 3. My answer should be 4 over 3. So with that, 2 plus root k should be 4, root k should be 2, k should be 4, right? Okay, so the two ways of thinking on how to find the value of k. Okay, I'm going to do b over here. So b is also another case of factorization. Yeah, you can see the limit of x approaching -1. Okay, the problem is I cannot factorize the top, yeah, the numerator. You can see this will be x squared minus 2x minus h. This is kx plus 2 equals -2. So I know that if I put -1 inside your x, I should get 0, because only then you will get 0 over 0 in determinate form. So what I'm going to do is I take my denominator, I sub -1 inside, I plus 2, I let it be 0. So negative k is now -2, k is just 2. Okay, how about h? If I know k is 2, we can now substitute. Okay, let me put it this way, x squared minus 2x minus h. This is now 2x plus 2, and this limit is -2. So I know I can factorize the denominator. So when you factorize the denominator, right? Okay, this is the difficult part. Okay, I will have 2x plus 1. So at the same time, I'm going to factorize the numerator. I know I should be able to cancel out this, right? So to cancel out this, what do you think I should put inside? See, I have a negative h here. So obviously this must be negative h. Am I right? So that when you expand, you should get x squared plus, okay, I'm just going to write this straight here. So when you compare your numerator means the one on top, my x minus h and x plus 1 must be x squared minus 2x minus h. So when you expand, you will get 1x minus hx, right, minus h. This result is here. Okay, if you find it difficult to do mentally, I actually do quite fast here. This is actually 1x minus hx. I just factorize the 1 minus h. And I will compare this with this. So by comparing the coefficient of x, I will be able to get the value of h. See, 1 minus h is -2, h is just 3. So since the question asks for h plus k, so I know h plus k is 3 plus 2, answer is 5. Okay, one thing you can do to check, so let me just perform a check on this, right? For question B, we know this is limit of x approaching -1. Now that my h is 3, so I'm going to write x squared minus 2x minus 3. Now that my k is 2, so we know we can factorize x minus 3, x plus 1, and this is 2x plus 1. When you cancel and substitute -1 inside, you get -1 minus 2 minus 3 over 2. This is -2, which is the same as given question. See, the question gave us -2. Yeah, so I know this is a bit more difficult, not so straightforward, right? Okay, so okay, we'll move on to the next one. Okay, differentiate by using the first principle. This is the annoying part. So I think I will have to do maybe part A and B in this page, and then part I'll have to erase it and do, or just move it down and do C and D below. Okay, I may have a bit of a space constraint. So let's do A first. Now we call y equals 5x minus 8 as equation 1. Remember, you always have to sub in x plus delta x and y plus delta y to form the second equation. So your y plus delta y is now 5x plus delta x minus 8. So when you expand, you get 5x plus 5 delta x minus 8. equation number 2. When you take equation 2, subtract equation 1. Now I just like to cancel all the one, sorry, without delta. So you know, when you take 2 minus 1, these two cancel off. The one without delta will be crossed off. So you're left with delta y, and it's 5 delta x. So delta y over delta x is just 5. Now this is called the gradient of your chord. So for straight line, it's very easy. We know the answer is going to be 5, right? The gradient of a straight line is fixed. It's your mx plus c is just 5. But since we just have to show this, right? Dy dx your gradient tangent. We take the limit of delta x approaching 0. All right, and I'm going to put my delta y over delta x inside. Remember, the formula is the first principal formula. Dy dx is limit of delta x approaching 0 of delta y over delta x. So there's nothing to sub inside, so your answer is just 5. Okay, oh, this line is not so straight. Draw time. Now I'm going to do b over here. C and d I'm going to write below. So here I got y equals to x squared minus x, first equation. My second equation, so can I just write y plus delta y? Don't need to write the sub. X plus delta x squared minus x plus delta x. Okay, let us expand the bracket first. And I hope you already know in the previous question, I've already shown you 2x delta x squared. Yeah, the negative I times inside second equation. So by taking equation 2 minus 1, we'll just strike off all the one without delta y delta x. Cancel this, cancel this, cancel this. Okay, so what do you have left? You have delta y equals to x delta x plus delta x squared minus delta x. So dividing by delta x, so delta y over delta x will give us 2x plus delta x minus 1. And remember, dy dx is the limit of delta x approaching 0. I'm just going to substitute 0 inside here. So if you sub 0 inside, don't need to write, you're left with 2x minus 1. Okay, part C, I'm going to do it here, y equals to x plus 1 square, and part D, I'm going to do it here, y equals 1 over 4x. Okay, let me move this up. Okay. Okay, so for part C, again, this is your equation 1. Equation 2 will be y plus delta y equals x plus delta x plus 1. We replace your x with delta x. Now, I think it's actually easier to switch this position. Yeah, we know that when you expand a plus b squared, you should get a squared plus 2ab plus b squared. Now this will be your a now, this will be your b now. So when you expand your, okay, I'll just keep writing this, your a is now x plus 1 square, 2ab, now 2ab, and your b squared. So this will be my equation 2, right? It's actually easier that way, so that I don't have to expand the entire bracket. So the next thing is, I'm going to take equation 2 minus equation 1. And again, the concept that I mentioned, just cancel the one without delta x. You can just cancel it, right? And now you're left with delta y equals 2x plus 1 delta x plus delta x squared. Dividing it with delta x, delta y divide delta x is 2x plus 1 plus delta x, right? And what is dy dx? Dy dx is the limit of delta x approaching 0. Let us put this delta x inside. Yeah, replace this with 0, right? So you just get 2x plus 1. That's your answer. But if you want, you can actually multiply inside, right? And get 2x plus 2. All right. D, this is your equation 1. Equation 2 will be y plus delta y, 1 over 4 x plus delta x. Equation number 2. When you take 2 minus 1, now this one, take note that you cannot cancel this 2. You cannot just cancel this. No, you can't cancel that. So this is a bit unique because you have to subtract 1 by 1. So delta y, yes, left. The y you can cancel though. 1 over 4 x plus delta x minus 1 over 4x. Okay. To subtraction, we know that they must have the same denominator, right? So on this term here, I need to multiply top and bottom by x. I don't have x, right? on this term on the right here, I don't have x plus delta x because your common denominator should be 4x x plus delta x. So what I don't have on the right, maybe I just use blue pen to show you. Okay, what I don't have on the left is I need to multiply x multiply x. I need to multiply x plus delta x and x plus delta x. So when I do that, I will get x and I get negative bracket x plus delta x. Okay, the negative, when you open up the bracket, x minus x disappear, you're left with negative delta x over 4x x plus delta x. Okay, this is a bit ugly, let me fix this. All right, so and remember what we want to find is delta y over delta x, gradient of my chord, negative 1 over 4x x plus delta x, and therefore my dy dx is the limit of delta x approaching 0. Let us just put 0 inside your delta x. So when I put 0 inside, I'm left with x plus 0 here, negative 1 over 4x squared. All right, okay, so let's move on. Now let's look at number 6, and I think this is the last one. So the displacement of a squirrel running on a straight cable for t seconds given by this function st equals to t squared minus 3t, where t greater equals 0. Using first principle, find the velocity. Okay, velocity is basically the rate of change of displacement. Yeah, I'm going to learn a lot more detail about displacement later on. So I think it's a bit hard for me to use s, then there'll be like delta s. It looks a bit confusing, so I'm just going to use y, and because this function is st, so we can just let my y equals to t squared minus 3t. Okay, instead of using x now, we use t. Then your second equation, remember you got to sub y plus delta y. This would be t plus delta t squared minus 3t plus delta t. So when you expand this, you get t squared plus 2t delta t plus delta t squared minus 3t minus 3 delta t. Equation number 2. As you take equation 2 minus equation 1, okay, maybe, yeah, I cancel straight away. Yeah, these two, cancel these two, cancel the one without delta t. Okay, take equation 2 minus equation 1. So your delta y is now 2t delta t plus delta t squared minus 3 delta t. So when you divide everything by delta t, you get 2t plus delta t minus 3. Yep. Now, what is velocity? Velocity is the rate of change of the displacement. In this case, is delta y over delta t. Yeah? So v is dy dt, which is the limit of delta t approaching 0 of your delta y over delta t. So we're going to replace delta t with 0. Your answer is 2t minus 3. Yeah, because the question says use the first principle, so we have to do that. And we're finding the velocity when t is 5. So we just substitute t with 5. You get 2 times 5 minus 3. 2 times 5 is 10. 10 minus 3 is 7 meter per second. Okay, so we're done, right? So before we go, yeah, just so you know that oh, I don't have it. Yeah, I have it here. All right, so we have more learning modules with video tutorial. If you're interested, you can find out more, yeah, together with our tuition classes, right, from our website, or WhatsApp us, or even call us. Yeah, I hope you enjoy this video and learn a lot in the process. Thank you. I will see you guys in the next video.